Good morning, 3F. Welcome to our HBL lesson. Today, I'm going to bring you through the remaining questions that are in our 10-year series. Please make sure that you have attempted the questions first prior to going through the answers that are in this video. For question 3, whereby you have a graph that is supposedly going to be half drawn, that is only the first half the graph is drawn, you are going to see the answers. You're going to see the questions that ask you to suggest what these results show about the effects of temperature on the rate of this reaction. So, given that you only have half the graph, you are expected to only answer from the temperatures from 0 degrees Celsius to 40 degrees Celsius. And you're supposed to only say what happens to the rate of this reaction. And so, with that, the rate of reaction from 0 degrees Celsius to 40 degrees Celsius, the rate of reaction increases. It says in part B that the student continues to measure the rate of this reaction at temperatures up to 80 degrees Celsius. On the graph B part 1, sketch how you would expect the line to continue from 40 degrees Celsius to 80 degrees Celsius. That is where you will notice earlier on that the graph had an extra area to it. I'm going to put that back in. And that is what you would see as your answer to B part 1, that you would extend the line out from the top of the graph down to 80 degrees Celsius. You can tell that they're going to ask the next question on the denaturing of enzymes at higher temperatures already, which is what you have. Using your knowledge of enzymes, explain why the rate of this reaction follows the graph line you have drawn, which means they only want the answers from 40 degrees Celsius onwards all the way to 80 degrees Celsius. So state that beyond 40 degrees Celsius, the temperature is too high, causing the enzyme to start to denature and causing it not to be able to catalyze the reaction as fast as before. That's for the first mark. Then, eventually, since the graph was sketched all the way to 80 degrees Celsius, you will state that at 80 degrees Celsius, the enzyme is fully denatured and no longer able to catalyze the reaction. And just as a tidbit, name the substrate and products of a lipase enzyme. Now, I know that this one for the next segment, which is in C part 1, this is for our upcoming chapter on digestion, but I'm going to give it to you at this point in time that the substrate that lipase acts on is fats, and the product forms as glycerol and fatty acids. So this is like a rehash of our previous topic on nutrients. Moving along, we have the question that asks you, a lipase enzyme acts only on one substrate. Explain why it does not act on other substrates. So, using phrases like specific three-dimensional active site, okay, we're going to add on to stating that the three-dimensional active site only allows for the shape of the substrate fats to bind to it. So, very key points over here. I'm going to draw in some lines to indicate the important points, such as three-dimensional active site, okay, allows for the shape of the fats to bind to it. So that's your first mark. And subsequently, we're going to state down that I'm going to use a different color to show that other substances, they have different shape and are, oh, there's a typo over here. I'm going to adjust it over here. That the different shape of the enzymes are not able to fit in over here. Give me a moment to move the mouse cursor properly over. They are not able to fit into the lipase's active site. So that should be are not able to fit at all. Okay, coming down to this question over here, whereby we're studying the effect of temperature on the activity of two enzymes X and Y. You're supposed to state down two differences in the activity of the enzyme shown. Okay, so the first marking point that we have is that enzyme X has an optimal temperature of 28 degrees, but where its enzyme activity is fastest, whereas enzyme Y has an optimum temperature of 34 degrees, where its enzyme activity is fastest. So that is one marking point. I'm going to put down there that this is one marking point over here. Subsequently, the second marking point, which is below, is that enzyme X has a lower maximum enzyme activity as compared to enzyme Y. You can see that the peak of enzyme X is only here, it's lower, and enzyme Y has a higher peak over here. All right, I'm going to move it back over here so that you can pause the video if you need to take down the answers to this question. And finally, we're supposed to explain the shape of enzyme X. So enzyme X, you can see that the graph goes up over here and eventually falls all the way down. And we're going to take note that there is the optimum temperature again over here. I'm going to draw a line to indicate it. Oops. Okay, there we go. Now we have a line that is somewhat around the 28 degrees Celsius range. Oops, something happened. My little diagram jumped. Let me see if I can pull it back. There we go. Okay. So, as temperature increases from 0 degrees Celsius to 28 degrees Celsius, the enzyme activity increases. And I think you should state in that the kinetic energy for the enzyme increases. Beyond 28 degrees Celsius, the enzyme is starting to get denatured, causing its enzyme activity to decrease until it reaches 48 degrees Celsius, where the enzyme activity stops. Okay, you can go ahead and pause at this point to take down some of the answers for these questions as well. Finally, moving on. Very important in a question that states down that you're supposed to use lock and key hypothesis. This is a quick indication that you are supposed to utilize the words locks and keys in this particular one. So the enzyme is your lock over here, and the key is your substrate, or the substrate is your key over here. So make sure you put that in, because like that, each of them is already worth 1 mark each. Then as we go along, we always talk about specific shape of the three-dimensional sites, like these over here. And since we're talking about the temperature being extremely high at this point, we're talking about it being at 60 degrees Celsius, we're going to state that it is also at this point that the temperature is too high, okay, causing enzyme to be denatured. So these are keywords that must always be part of your answer. And eventually, of course, you must state that because the active site has been denatured, the key, the substrate, is no longer able to fit in. Okay, remember to put all that in. So that wraps up this particular 10-year series answering 4 up to enzymes. Please make sure to complete it, get your corrections done, and submit it to me on Monday. Okay, please put it in my pigeonhole on Monday. I would really appreciate if Faith could also remind the rest of the students in the class to get this one done. Okay, so have a good weekend ahead. Thank you very much for watching this video. Take care. Bye-bye.